Silicon is the second most abundant element in the Earth's crust. It's a tetravalent metalloid and semiconductor that we most associate with its use in computers, but it's found in a lot of other really interesting places. One common source of silicon is silicon dioxide, or sand. And today I'm going to make pure sand from elemental silicon, and I begin by dissolving my silicon in a strong sodium hydroxide solution. This reaction between water, silicon, and sodium hydroxide will produce a very concentrated solution of sodium silicate. Sodium silicate itself is an extremely useful chemical with a massive array of uses, and I would consider looking into some of them if you're interested. In any case, once the silicon is mostly dissolved, I add some water to dilute it so that it won't dissolve my filter, and I pass it through a filter paper to remove all of the larger pieces. The result here is a pure and clean sodium silicate that I can then take and use in the next step of my process. If you look back in the video, you'll see that I dissolved half a mole of silicon. Since my final solution has a volume of 150 milliliters, this is probably around a 3 molar solution. With that number in mind, I quickly whip up a 2 molar sodium bisulfate solution and slowly add my sodium silicate to the bisulfate until a white solid begins to precipitate. The ethereal white gel that begins to form at the bottom is called orthosilicic acid, and it's a precursor for a wide variety of silica and silicon materials across the world. To finish precipitating it, I'm going to continue adding sodium silicate until the pH is strongly alkaline. Remember that the sodium silicate is alkaline and bisulfate is acidic, so these two are also neutralizing each other. Once the solution is strongly alkaline and all the orthosilicic acid has precipitated out, the solution becomes extremely thick and difficult to work with. To that end, I add a little bit of extra water, break it up, and pass it through a coffee filter to isolate my orthosilicic acid. The orthosilicic acid is then transferred to a ceramic or porcelain dish for the final phase of this process. Now, to finally make my silicon dioxide, I'm going to heat my orthosilicic acid to decomposition, which is going to drive off moisture and leave behind silicon dioxide. This part of the process can also be manipulated to produce other silicate materials such as silica gel, quartz, opal, aerogel, and a couple other things. For sand though, I just keep heating until my final product is pure, white, crystalline silicon dioxide. And this is sand. However, in lab, we would more refer to something like this as being silica or fused quartz, but it's really the same thing. In any case, I hope you enjoyed this project, and if you'd like to see more like it, consider giving me a follow on here or subscribe to my YouTube at Integral Chemistry. Following or subscribing is a way you can really help support this channel without giving a dime, so give it a thought.